Last page. First question, workers in Australia and New Zealand can each produce sheepskins and possum pelts. An Australian worker can produce 20 sheepskins or 50 possum pelts, presumably, in a month, there we go. New Zealand worker can produce 10 sheepskins or 40 possum pelts, because obviously New Zealanders are worse than Australians. Who wrote this question? Okay. Circle which country has which type of advantage. Okay, Australians are better at producing sheepskins than New Zealanders, 20 versus 10. They have an absolute advantage in sheepskins. They also have an absolute advantage in possum pelts, 50 versus 40. Whoops, wrong one. Okay, on that time it didn't move, what the heck. Okay, comparative advantage is who can do it with the lowest opportunity cost. Okay, well, to produce 20 sheepskins, the Aussie worker would give up 50 possum pelts. To produce the same number of sheepskins, it's going to take the New Zealander 2 months, and in that time they could produce 20 sheepskins or 80 possum pelts. Okay, well, the comparative advantage at sheepskins then is going to be for the Australian guy. The Australian worker only has to give up 50 possum pelts to produce 20 sheepskins. So comparative advantage on sheepskins for Australia, and automatically we can say then comparative advantage at possum pelts for New Zealanders. But just in case we needed to check that out, we'd say, okay, in the time it takes the New Zealander to do, the Australian to do 50 possum pelts, they could do 20 sheepskins. We're giving up 2/5, that is 20 over 50 of a sheepskin per possum pelt. For the New Zealander, it's 10 over 40 is 1/4. They give up 1/4 of a sheepskin per possum pelt. 2/5 is bigger than 1/4, so the New Zealander has the lower opportunity cost of producing possum pelts. So then if these are the only two countries, who should do what? The one that has the comparative advantage should do that thing. So comparative advantage, Australia for sheepskins and New Zealand for possum pelts. Lastly, suppose a worker receives $100 for a sheepskin. So an Aussie worker gets $2,000 producing sheepskins, and a New Zealand worker, a Kiwi worker, gets $1,000. What are the minimum and maximum prices possum pelts could be to induce everyone to produce the correct products? Okay, well, we want the Aussie guy to produce sheepskins, so we've got to make sure that possum pelts wouldn't give them too much money. Okay, so they can produce 50 possum pelts. If possum pelts cost $40, I found 40 by doing 2,000, the monthly salary for the Australian worker making sheepskins, divided by 50, the number of sheepskins number of possum pelts they could produce in a month. That gives 40. And so if the price of possum pelts was bigger than 40, they could get more than $2,000, and so would switch to possum pelts. So 40 is the most then that we could pay for possum pelts while still making the Australian worker want to produce sheepskins. For the minimum price, we have to convince the New Zealand worker to produce possum pelts. We know they could get $1,000 if they produced sheepskins. So we've got to make sure that they get at least $1,000 producing possum pelts. Well, they can produce 40 possum pelts, and 40 times, well, actually, let's do 1,000 divided by 40 possum pelts gives us 25. Okay, then if we got paid at least $25 per possum pelt, we produce 40 and we get at least $1,000. So anything in the range 25 to 40 would induce the Aussie guy to produce sheepskins and the Kiwi guy to produce possum pelts. Okay, that one's definitely a little tricky. We haven't seen too many problems like that before. That's one, if you were not understanding that at first, I wouldn't be too worried. We're not going to see too many problems like that, I shouldn't expect. Okay, finally, in the country of Corruptistan, we have 5 grad students, A, B, C, D, and E. Each of them can bribe a professor to sponsor them for a PhD. All those professors have fun names as well, W, X, Y, and Z. I guess Professor X is an actual dude, right? Don't tell me that's just a comic book character. And so here are the amounts each of the students is willing to pay for a PhD. So those are going to be our buyers. Here are the sellers. The sellers are going to sell a PhD, and here's the lowest cost that they would, lowest price they would accept, the lowest bribe. All right, let's answer our 3 questions. If the university would only allow 1 professor and 1 grad student to match, what's the maximum economic surplus? Well, then we should match the highest willingness to pay with the lowest willingness to sell. A should learn from W. A gets $500 worth of benefit. W has a cost effectively of $200, so we get $300 surplus that could be split between A and W somehow. Next, the university is going to enforce a minimum bribe of $425. Okay, well, all the professors would be willing to take that bribe, but only 2 students would be willing to pay that bribe. Okay, if we wanted the most surplus possible, the greatest amount of producer surplus, we would want the professors that have the lowest willingness to pay. That's these 2, sorry, lowest willingness to sell. And they are going to charge $425, it looks like. So 425 minus 200 is 225 for the first professor. The second professor, 425 minus 275 gives us 150. Add those together, we've got 375. Last one, green looks like a good colour. What's the efficient number of PhDs? Well, this one's going to be even. This is the easiest of the lot. We match them up until we can't match anymore. So match them up from highest willingness to pay to lowest willingness to sell. Those 2 can match. These 2 can match. These 2 can match. But now these ones can't. And so we're left with 3 PhDs being produced.